Two, two.
Hi, my name is Daeng Danish Hamza bin Daeng Amir, and my matrix number is 221084. Okay.
Hi there, my name is Faathir and Firdaus. My metric number is 221200.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azri Hazim bin Sharizal. My matrix number 221024.
Assalamualaikum warahmatullahi wabarakatuh. Today my group will present about computer keyboard. My name is Faris bin Soimi and my metric number is 221281. Okay, for the agenda today, we will discuss the key topics in this presentation, which is about reasons computer keyboards were made and how computer keyboards work. And we also add physics application in computer keyboards. First, I will explain to you about history of the computer keyboard. The development of the first modern computer keyboard was occasioned by the invention of typewriters, with the first practical modern typewriter patented by Christopher Latten Scholes in 1867. There is his picture. Scholl, Whedon, and Soule are the initial minds behind the most popular QWERTY keyboard layout. The first computer keyboards came from the key punches and teletype equipment. From the early 1940s until the late 1960s, typewriters were the primary means of data entry and the output for computing, becoming integrated into what was known as computer terminals. Whirlwind was the very first computer in the world to enable its users to feed data and programs into the computer using a keyboard. It further confirmed how convenient and helpful the keyboard input device was.
And the reason the keyboard was invented is to provide a fast and efficient way to input information into a machine. The first keyboards were developed for telegraph operators in the year 18s, but they were becoming more widely used with the advent of typewriters in the the 19th century. The modern computer keyboard evolved from typewriter keyboards and has become an essential tool for inputting the text and commands into computers. Keyboards have also been adapted for other devices such as smartphones, tablets, and to provide convenient way to enter text on these devices.
So right now we're moving on to how keyboard works. So keyboard works on certain keys such as, yeah, as you can see, alphanumeric keys, modifier keys, function keys, navigation keys. These all are types of keyboard keys. Okay, so we move on to the physics part and its application in the computer keyboards. So computer keyboards exactly applied a concept that named as a capacitor. So what is a capacitor? Capacitor is any combination of two separated conductors that can act as an electrical circuit element and is called capacitor. So capacitance of a capacitor is defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between conductors. So let's learn how do capacitor work. As you can see, there's a figure here showing how capacitor work. So if the capacitor is initially uncharged, the battery establishes an electric field in the connecting wires when the connections are made. The electric field in the wire applies a force on electrons in the wire immediately outside this plate. This force causes the electrons to move onto the plate. The movement continues until the plate, the wire, and the terminal are all at the same electric potential. Potential difference no longer exists between the terminal and the plate. As a result, no electric field is present in the wire and the electrons stop moving. So the plate now carries negative charges.
Why capacitors are used in keyboards? Capacitors are used in keyboards in computers for specific purposes. A. Energy storage. Keyboards often have backlighting or other features that require a temporary power source. Capacitors store electrical energy and releases it when needed, providing a short-term power supply for these functions. B. Debouncing. When a key is pressed on a keyboard, it can sometimes generate multiple electrical signals due to mechanical vibrations. Capacitors can be used in debound circuits to filter out these unwanted signals and ensure that the only a single keystroke is registered when an individual types. That's all from me. Thank you.
All right, next it goes to the capacitors in the keyboard. In the left side, in figure 25.3, this is the capacitors in the keyboard. Okay, first we have the surface charge density. For every plate, they have surface charge density, which is omega equal to Q over A. And then the value of the electric field between the plates is the formula is E equal to omega over E naught and equal to Q over E naught A. And because the fields between the plates is uniform, the magnitude of the potential difference between the plates is the delta V equal to ED, and ED is equal to QD over E naught A. So we can we can derive the equation to become C equals to Q over delta V, and then the delta V we substitute with the ED, and it become C equal to E naught A over D, which means that whenever the distance between the movable plates becomes shorter, and means that the capacitance in the keyboard becomes larger. All right, next part is how do capacitors work in the keyboard? Okay, first, the capacitance switches in the keyboard consist of two conductive plates separated by a non-conductive material called dielectric. When a, when a key is at rest, the movable plate, which is connected to the keycap, is positioned above the fixed plate but does not touch it, forming a capacitor. When the key is pressed, the movable plate moves closer to the fixed plate, reducing the distance between them and increasing the capacitance. The capacitance of each switch, the keyboard circuitry includes a capacitor sensing circuit that monitors the capacitance and each switch. It applies a small electrical charge to the fixed plate and measures the resulting capacitance. The change in the capacitance when a key is pressed is detected, allowing the keyboard to register the key press and send the corresponding signal to the connected device. All right. All right, the conclusion for our presentation is, in conclusion, the study of physics not only deepens our understanding of the natural world, but also has profound applications in our daily lives. Throughout the presentation, we explore various concepts and their practical implications, highlighting how physics shapes and enhances our experience. Physics also plays a vital role in the technology we rely on, from the development of electronics and telecommunications to the advancements in medical imaging and treatment. Physics underpins the creation and operation of these essential devices and systems. Concepts such as electricity, magnetism, And optics are the core of modern technology, enabling us to communicate, explore the universe, and improve healthcare outcomes. All right, that's all from our group. Thank you.